Imagine standing under the sky and feeling the warmth on your skin. That light you feel is not just simple sunlight. It is energy that has traveled more than 149 million kilometers, taking over 8 minutes to reach Earth. The sun is not just a bright circle in the sky. It is a giant star, a living engine of fire and power, holding our entire solar system together. Without it, there would be no light, no warmth, and no life. Today, we will begin a journey into the heart of this star. Step by step, we will reveal 100 unique facts about the sun. Some of them will amaze you, some will challenge what you thought you knew, and all of them will remind you how incredible our universe really is. Let us begin. Fact number 1. The sun contains more than 99.8% of the total mass of our solar system. That means almost everything you see in the sky, from the giant planets like Jupiter and Saturn, to the tiny moons and asteroids, together they make up less than 1%. Imagine placing all the planets on a giant scale. On the other side, you place only the sun. The sun would crush the scale instantly because it is hundreds of times heavier than all the planets combined. This incredible weight is what gives the sun such powerful gravity. It is the invisible force that keeps Earth moving in its orbit, that guides the paths of all the planets, and that holds the entire solar system together. Without this massive center of gravity, everything would drift away into the cold emptiness of space. Fact number 2. The sun is so large that more than 1 million Earths could fit inside it. Try to imagine this. Take our planet, the mountains, the oceans, the cities, every single part of Earth, and place it inside the sun. Now, make copies of Earth again and again, and keep placing them inside. You would need over 1 million Earths just to fill the sun completely. This incredible size is why the sun looks so powerful in the sky, even though it is so far away. From Earth, the sun may look small, like a glowing circle, but in reality, it is a giant sphere of fire and gas, a star so large that our world is only like a tiny grain of sand compared to it. The sun is not only massive, its size is the reason why it can burn for billions of years, producing light and heat that make life possible here on Earth. Fact number 3. The light you see from the sun does not appear instantly. It takes time to travel across the vast distance of space. From the surface of the sun to the surface of Earth, light needs a little more than 8 minutes. That means when you look at the sun, you are not seeing it as it is right now. You are seeing it as it was 8 minutes ago. Imagine this. If the sun could suddenly disappear this very second, we would not notice it right away. For over 8 minutes, the sky would still look bright. The world would still feel warm, and life would continue as if nothing had happened. Only after those 8 minutes would darkness cover the Earth. This delay reminds us how enormous space truly is. Even something as fast as light, the fastest thing in the universe, still needs time to reach us from our star. Fact number 4. The Sun is about 150 million kilometers away from Earth. This distance is so great that it is hard to imagine. If you could somehow drive a car straight into space at normal highway speed, it would take more than 170 years to reach the Sun. Even if you flew in a jet plane without stopping, it would still take almost 20 years to arrive. This distance is what protects us. If Earth were much closer, our oceans would boil away. If it were much farther, our planet would be a frozen world. The Sun and Earth are placed at just the right distance, a perfect balance that allows life to exist. Astronomers call this the habitable zone, the place around a star where life can survive. Earth is lucky enough to be right inside that zone, warmed, but not destroyed by the power of the Sun. Fact number 5. The Sun is almost a perfect sphere. When most people look at the Sun, they imagine it as a flat circle in the sky. But in reality, it is a giant ball of hot gas. Astronomers have measured its shape and discovered something amazing. The Sun's diameter from one side to the other is nearly the same in every direction. This means the Sun is one of the roundest natural objects ever found in the entire universe. If you could shrink the Sun down to the size of a beach ball, the difference between its widest and narrowest parts would be thinner than the width of a single human hair. Its perfect shape comes from the force of its own gravity, pulling all of its fiery material inward toward the center. That balance of fire and gravity creates a star that burns evenly, glowing with steady light for billions of years. Fact number 6. The Sun is made almost entirely of two elements, hydrogen and helium. About 3/4 of the Sun is hydrogen, and most of the rest is helium. These are the two lightest elements in the universe, but when they are packed together under the Sun's enormous gravity, they create incredible power. Deep inside the core, hydrogen atoms are forced together in a process called nuclear fusion. This fusion turns hydrogen into helium and releases enormous amounts of energy. It is this process that makes the Sun shine. Every second, the Sun converts more than 600 million tons of hydrogen into helium. The leftover energy bursts outward as heat and light, traveling across space to reach Earth. That is the fire you feel on your skin every sunny day. Fact number 7. The Sun is not a solid object. It is a giant ball of plasma. Plasma is a special state of matter, different from solids, liquids, or gases. In the Sun, the extreme heat rips atoms apart, leaving only charged particles of protons and electrons swirling together. Because of this, the Sun behaves very differently from anything on Earth. Its surface is constantly boiling, bubbling, and moving. Gigantic waves of plasma rise and fall, while powerful magnetic fields twist and snap, creating explosions of light and energy. This ocean of plasma is alive with motion. It is the reason why the Sun is always active, never still. and always sending streams of energy out into space. Without plasma, the sun would not shine, and Earth would remain a cold and lifeless world. Fact number 8. The surface of the sun, called the photosphere, is incredibly hot, reaching about 5,500 degrees Celsius. That is hot enough to melt any material known on Earth in an instant. Yet, compared to the sun's core, this surface is actually cool. Deep inside, the core burns at more than 15 million degrees Celsius, a temperature so extreme that atoms are forced to fuse together. The photosphere is the layer we see with our eyes every day. It looks calm and smooth from far away, but up close, it is a boiling sea of fire, with giant cells of gas rising and sinking like bubbles in a pot of hot water. Every ray of light that warms Earth begins its journey here, escaping from the photosphere before traveling across the vast distance of space to reach us. Fact number 9. The outer atmosphere of the sun, called the corona, is hotter than the surface itself. This sounds impossible at first. The photosphere, the visible surface, burns at about 5,500 degrees Celsius. But the corona, the faint glowing halo you can only see during a total solar eclipse, can reach temperatures of more than 1 million degrees Celsius. Scientists are still searching for the reason behind this mystery. Some believe powerful magnetic waves rising from deep inside the sun carry energy into the corona, heating it to extreme levels. Others think tiny explosions happening constantly on the surface may be the cause. Whatever the answer, this strange fact shows us that the sun is full of secrets. And even with all our technology, it still holds mysteries we have not yet solved. Fact number 10. Sunlight that reaches Earth today began its journey inside the sun thousands, even millions of years ago. In the sun's core, energy is created by nuclear fusion. But this energy does not rush straight out. Instead, it begins a long and difficult journey through the dense inner layers of the sun. Photons, the tiny particles of light, are trapped in a crowded maze, bouncing and scattering endlessly. It can take thousands, sometimes even millions of years, for one photon to finally escape from the deep core to the surface. Only then does it travel freely through space, needing just a little more than 8 minutes to reach Earth. So when you feel the warmth of the sun on your skin, remember this: the light touching you today was born a very, very long time ago in the heart of a star. Fact number 11. The sun is constantly spinning, but it does not rotate the way Earth does. Earth spins as a solid ball, turning once every 24 hours. The sun, however, is made of plasma, so different parts of it spin at different speeds. At the equator, the sun makes a full rotation in about 25 days. But near the poles, it takes more than 30 days. This strange difference is called differential rotation. It stretches and twists the sun's magnetic fields, creating powerful storms, sunspots, and even huge explosions of energy. So while the sun may look calm from far away, in reality, it is twisting, spinning, and boiling with motion, a living star that never truly rests. Fact number 12. The surface of the sun is not smooth. It is covered with dark spots, called sunspots. Sunspots may look small when seen through a telescope, but in reality, many of them are larger than the entire Earth. These spots are cooler areas on the surface, caused by powerful magnetic fields rising from deep inside the sun. When the sun has many sunspots, it is in a period of high activity. This can lead to giant solar flares and eruptions that throw huge amounts of energy into space. When it has fewer sunspots, the sun is in a quieter phase. These cycles of activity repeat roughly every 11 years, like the heartbeat of the sun. They remind us that our star is not just a steady light in the sky, but a dynamic and ever-changing force of nature. Fact number 13. The sun produces powerful explosions called solar flares. A solar flare is a sudden burst of light, heat, and radiation caused when magnetic energy on the sun is released all at once. These explosions can be so strong that they release more energy in a few minutes than millions of nuclear bombs exploding at the same time. When aimed toward Earth, solar flares can disturb satellites, damage communication systems, and even cause power outages on the ground. They also create brilliant auroras, colorful lights that dance across the skies near the North and South Poles. Solar flares are a reminder that our star is alive with energy, and even from millions of kilometers away, its power can still touch and shape our world. Fact number 14. Sometimes the sun releases gigantic eruptions called coronal mass ejections, or CMEs. Unlike solar flares, which are bursts of light and radiation, a coronal mass ejection throws billions of tons of solar material into space. Imagine a massive cloud of charged particles, larger than entire planets, blasting out at millions of kilometers per hour. When one of these clouds heads toward Earth, it can shake our planet's magnetic field. This can cause bright auroras, but it can also disrupt satellites, navigation systems, and power grids. The largest event ever recorded, known as the Carrington event in the year 1859, caused telegraph systems around the world to spark and fail. Coronal mass ejections remind us that even though the sun gives us life, it also has the power to challenge our modern technology in ways we are still learning to understand. Fact number 15. The gravity of the sun is the glue that holds the entire solar system together. Without the sun's enormous pull, Earth and all the other planets would drift off into the emptiness of space. It is the sun's gravity that keeps Earth moving in its orbit, giving us days, nights, and seasons. This same force controls the paths of comets, asteroids, and even the tiny particles of dust floating in space. Everything within the solar system, from the largest gas giant to the smallest grain of rock, is dancing to the rhythm set by the sun's gravity. In many ways, the sun is not just our source of light and heat. It is also the invisible anchor, the steady hand that keeps the cosmic family of planets and moons bound together in harmony. We have seen how massive the Sun is, how it holds the solar system together, and how its gravity and size shape everything around it. But the true power of the Sun is not only in its size. It lies in the unimaginable energy burning at its heart, energy so intense that it lights up the entire solar system, warms our planet, and makes life possible on Earth. In the next part of our journey, we will dive into the fiery core of the Sun. We will explore its incredible heat, the process that makes it shine, and the secrets of the energy that has fueled our world for billions of years. Let us continue with the next fact. Fact number 16. The core of the Sun is unimaginably hot, reaching more than 15 million degrees Celsius. This is the very heart of the star, a place of crushing pressure and incredible heat. At these extreme conditions, atoms of hydrogen are forced together, fusing into helium. This process, called nuclear fusion, is what creates the Sun's energy. Every second, the core produces more power than humanity could ever dream of using. It is enough to light and heat the entire solar system, to drive the winds and the oceans of Earth, and to sustain life in every corner of our planet. The core is a reminder of just how small we are compared to the forces of the universe. It is a furnace beyond imagination, burning for billions of years, steady and relentless. Fact number 17. The surface of the Sun, called the photosphere, is far cooler than its core, but still incredibly hot. It burns at about 5,500 degrees Celsius. To compare, the hottest lava on Earth reaches a little over 1,000 degrees Celsius. That means the Sun's surface is more than 5 times hotter than even the most violent volcanic eruption on our planet. From far away, the photosphere looks calm and smooth. But if you could see it up close, you would discover a restless ocean of fire. Giant cells of gas rise and fall like boiling water, each one larger than whole continents on Earth. This fiery layer is where sunlight begins its final journey into space. It is the surface that makes the Sun shine in our sky every single day. Fact number 18. The outer atmosphere of the Sun, known as the corona, is hotter than the surface itself. While the photosphere burns at about 5,500 degrees Celsius, the corona can reach more than 1 million degrees Celsius. This is one of the great mysteries of solar science, because usually, the farther you move from a heat source, the cooler it becomes. But with the Sun, it is the opposite. Scientists believe that magnetic forces and constant waves of energy shoot upward from the surface, heating the corona to these extreme levels. Yet, even today, the exact reason remains uncertain. The corona is visible during a total solar eclipse, when the moon blocks the bright surface and reveals a glowing crown of fire stretching far into space. It is both beautiful and a reminder of how many secrets our star still holds. Fact number 19. Every single second, the Sun releases more energy than humanity has used in its entire history. The power comes from nuclear fusion in the core, where hydrogen is turned into helium. In that process, a small part of the mass is transformed into pure energy. According to the famous equation, E equals mc squared, even a tiny amount of mass can create an enormous amount of energy. The result is staggering. In 1 second, the sun produces enough energy to supply Earth for millions of years at our current level of technology. Yet most of this power rushes outward into space, spreading in all directions, with only a small fraction reaching our planet. It is this endless supply of light and heat that makes Earth a living world. Without it, our planet would be a frozen and silent place, drifting in darkness. Fact number 20. Every second, the sun releases the same amount of energy as billions of nuclear bombs exploding all at once. This unimaginable power is what lights our world, drives our weather, and fuels every living thing on Earth. Without it, plants could not grow, animals could not survive, and human life would not exist. Yet the sun does not burn like firewood or coal. It shines through nuclear fusion, a process so efficient that it allows the sun to keep burning steadily for billions of years without running out of fuel. When you feel the warmth of sunlight on your skin, remember this: it is the touch of a cosmic engine, a star whose power is beyond anything humanity could ever create. The sun is not just our light in the sky. It is the very heartbeat of life on Earth. We have seen the unimaginable power of the sun, a furnace of energy that lights up the entire solar system. But now, let us look deeper, beyond the blinding glow. The sun is not just a ball of fire. It is made of layers, each one with its own role, its own mysteries, and its own beauty. From the hidden core at the center to the fiery surface we see in our sky, and all the way out to the ghostly corona that stretches into space. Every layer tells a different story about how our star truly works. In the next part, we will uncover these hidden layers and reveal what makes the sun such a complex and fascinating star. Fact number 21. At the very center of the sun lies the core, the true engine of our star. The core is where everything begins. It is a place of unimaginable pressure and heat, where the weight of the sun itself pushes atoms of hydrogen so close together that they fuse into helium. This process, called nuclear fusion, is what creates the sun's endless supply of energy. Inside the core, temperatures soar to more than 15 million degrees Celsius. Imagine every volcano on Earth erupting at the same time, and then multiply that power by billions. That is only a fraction of the force inside the sun's heart. Without the core, the sun would be nothing more than a cold ball of gas. But because of it, light reaches Earth, plants grow, oceans flow, and life is possible. The core is not just the center of the sun. In a very real way, it is also the center of our existence. Fact number 22. Surrounding the core of the sun is the radiation zone, a vast region where energy slowly makes its way outward. In this zone, light does not travel freely. Instead, it bounces from one particle to another, like a traveler lost in a never-ending maze. Each photon of light can take thousands or even millions of years to finally escape this region. The temperature in the radiation zone is still extremely high, starting from several million degrees near the core and dropping to about 2 million degrees at its edge. Even though the energy is immense, the dense matter slows it down, trapping the light in a long and winding journey. This means that the sunlight warming your face today may have started its journey in the sun millions of years ago, long before human civilization even began. The radiation zone shows us how patient the universe can be, moving in timescales far beyond human imagination. Fact number 23. Above the radiation zone lies the convection zone, a restless layer where energy finally begins to move in giant, rolling currents. In this zone, the hot gases from deep inside the sun rise upward, while cooler gases sink downward, creating powerful loops of motion. It is very much like the way water boils in a pot, with bubbles rising and falling again and again. The temperature here is lower than the inner zones, dropping to about 2 million degrees near the bottom and about 5,500 degrees at the surface. Yet the movement of gas makes this layer incredibly dynamic, full of turbulence and constant change. These powerful currents carry the sun's energy all the way to the surface, where it is released as the sunlight that brightens our world. The convection zone is the final gateway that allows the power of the sun to escape into space. Fact number 24. The photosphere is the visible surface of the sun, the part that shines in our sky every single day. Even though it looks like a solid surface from far away, the photosphere is actually made of glowing gas. It is about 500 kilometers thick, which may sound thin compared to the size of the sun. Yet it is the layer that gives the sun its familiar golden face. The temperature of the photosphere is around 5,500 degrees Celsius. To our eyes, it looks calm and steady, but in reality, it is constantly boiling and bubbling with massive currents of energy. This is the layer where sunlight begins its final journey through space. When you look at the sun through a safe filter or during a sunrise or sunset, you are seeing the light that comes directly from the photosphere. It is the glowing skin of our star. Fact number 25. Just above the photosphere lies the chromosphere, a thin but fascinating layer of the sun's atmosphere. The word chromosphere means sphere of color, and it was given this name because of its beautiful reddish glow. This glow is usually hidden by the bright photosphere, but during a total solar eclipse, when the moon blocks the surface of the sun, the chromosphere briefly reveals itself like a thin red rim of fire. The chromosphere stretches for about 2,000 kilometers above the photosphere. Its temperature is not steady. It begins around 4,000 degrees Celsius near the bottom, then strangely grows hotter as it rises, reaching up to 20,000 degrees Celsius near the top. This mysterious rise in temperature hints at the powerful magnetic forces and waves of energy that flow through the sun. The chromosphere may look delicate, but it is a window into the restless and unpredictable nature of our star. Fact number 26. The outermost layer of the Sun's atmosphere is called the corona, a glowing crown of light that stretches millions of kilometers into space. Most of the time, the corona is invisible because the photosphere is so bright. But during a total solar eclipse, when the moon covers the sun's surface, the corona appears as a ghostly halo surrounding the darkened sun. It is one of the most breathtaking sights in all of astronomy. The temperature of the corona is astonishing. While the surface of the sun is about 5,500 degrees Celsius, the corona can reach more than 1 million degrees Celsius. Scientists are still trying to understand how this outer layer can be so much hotter than the surface below it. The corona is not only beautiful, it also sends streams of charged particles across the solar system, shaping the space environment around every planet, including Earth. It is both a crown of light and a force that reaches far beyond the sun itself. Fact number 27. On the surface of the sun, there are often dark patches called sunspots. These spots are not holes, but regions that are slightly cooler than the surrounding areas. While the photosphere burns at about 5,500 degrees Celsius, sunspots can be 1,000 to 2,000 degrees cooler. This difference in temperature makes them appear dark against the bright surface. Sunspots are caused by intense magnetic activity. The sun's magnetic fields twist and tangle, blocking the flow of energy from below. As a result, these cooler regions form, sometimes growing so large that several Earths could fit inside a single sunspot. The number of sunspots changes over time, following an 11-year cycle. When sunspots are numerous, the sun is more active, producing stronger solar flares and more powerful storms in space. These dark patches are signs of the sun's restless and ever-changing nature. Fact number 28. If you could look closely at the surface of the sun with a powerful telescope, you would see a pattern that looks like tiny bubbles or grains. These patterns are called granules. Each granule is the top of a convection cell, where hot gases rise from below, release energy at the surface, and then sink back down as they cool. This movement creates a constantly shifting pattern, like the surface of boiling water. A single granule is huge compared to our world. On average, each one is about 1,000 kilometers wide, which means it could easily cover an entire country on Earth. Granules only last for a few minutes before fading and being replaced by new ones. Together, they give the sun's surface a dynamic, shimmering texture. What looks smooth and steady from Earth is, in truth, a restless ocean of fire in constant motion. Fact number 29. Beyond the small patterns of granules, the sun's surface also shows much larger patterns known as supergranules. Supergranules are enormous convection cells, sometimes reaching 30,000 kilometers across. To give a sense of scale, a single supergranule could stretch wider than twice the diameter of Earth. These giant cells move more slowly than regular granules, lasting for about a day before breaking apart and reforming. Within each supergranule, hot gases rise in the center and cooler gases sink at the edges. creating a flow that constantly reshapes the surface of the sun. Supergranules are so large that they influence the motion of magnetic fields across the photosphere. They play a role in shaping sunspots and in guiding the streams of plasma that form solar activity. They remind us that even the patterns of the sun are on a scale beyond human imagination. Fact number 30. Rising above the surface of the sun are gigantic loops of glowing gas called solar prominences. These structures are anchored to the photosphere and extend far out into the corona, following the invisible lines of the sun's magnetic field. A single prominence can stretch for hundreds of thousands of kilometers. Some are so large that the entire planet Earth could easily fit inside the curve of one of these fiery arches. Prominences are made of plasma, the same hot charged gas that fills the sun, and they can last for days, weeks, or even months. Sometimes, however, they become unstable and erupt into space, releasing enormous amounts of energy in a violent event called a coronal mass ejection. When stable, prominences look graceful and almost delicate, like ribbons of fire dancing in the solar atmosphere. They are among the most beautiful and dramatic features of our star, showing both its elegance and its power. We have journeyed through the layers of the sun, from its blazing core to the delicate arches of its prominences. Each layer reveals the structure of our star, the foundation that allows it to shine with such power and beauty. But the sun is not a calm or silent giant. It is alive with constant activity, explosions of energy, sudden storms of charged particles, and violent eruptions that can shake the space around it. These solar events do not stay on the sun alone. They can reach across millions of kilometers and touch our own planet, shaping the technology we use and the very skies we see. Now, let us step into the restless side of the sun and explore the powerful storms and activities that make our star both a giver of life and a source of danger. Fact number 31. One of the most dramatic events on the sun is a solar flare, a sudden and powerful burst of energy. A solar flare happens when magnetic energy in the sun's atmosphere is released all at once. In just a few minutes, it can release as much energy as billions of nuclear bombs exploding together. This makes solar flares the largest explosions in our solar system. The light and radiation from a flare travel across space at the speed of light, reaching Earth in just 8 minutes. While our planet's atmosphere protects us from the harmful radiation, solar flares can still disturb radio signals, satellites, and even power grids on Earth. Solar flares are a reminder that the sun is not simply a steady source of light. It is a star filled with violent energy, capable of sudden outbursts that can shake the space between worlds. Fact number 32. Sometimes, the sun releases not just light, but a massive cloud of charged particles in an event called a coronal mass ejection. In a coronal mass ejection, billions of tons of plasma are hurled into space at speeds of over 1 million kilometers per hour. These enormous waves of solar material can travel across the solar system and reach Earth in just a few days. When they collide with our planet's magnetic field, they can cause geomagnetic storms. These storms may look beautiful, creating glowing auroras in the night sky, but they can also be dangerous. Strong geomagnetic storms have the power to disrupt satellites, damage power lines, and interfere with communication systems. A coronal mass ejection is a reminder that the sun does not only shine peacefully. It can throw violent storms across space, storms so powerful that they can affect life and technology here on Earth. Fact number 33. Flowing constantly from the sun is a stream of charged particles known as the solar wind. The solar wind is born in the sun's corona, where the intense heat and magnetic forces push plasma out into space. This wind never stops. It blows in every direction, filling the entire solar system and carrying the sun's influence far beyond the orbit of Pluto. When the solar wind reaches Earth, our magnetic field acts like a shield, protecting us from most of the charged particles. But at the poles, some of the particles slip through, colliding with the atmosphere and creating the shimmering lights we know as auroras. The solar wind also shapes the boundaries of our solar system. Far out in space, it pushes against the thin gases between the stars, forming a protective bubble called the heliosphere. In this way, the breath of the sun stretches across billions of kilometers, guarding the planets like an invisible shield. Fact number 34. One of the most beautiful effects of the sun's activity on Earth is the aurora, often called the northern and southern lights. Auroras are created when charged particles from the solar wind collide with gases in Earth's atmosphere. These collisions release energy in the form of light, painting the sky with shimmering waves of green, red, blue, and purple. The shape and movement of auroras are guided by Earth's magnetic field, which pulls the particles toward the polar regions. This is why auroras are usually seen near the North and South poles. But during strong solar storms, they can spread much farther, even reaching areas closer to the equator. For thousands of years, people have looked up at auroras with wonder, sometimes with fear, and often with awe. They are a living reminder that the sun and Earth are deeply connected, and that the storms of our star can turn into breathtaking displays of light in our skies. Fact number 35. When powerful waves of solar wind or a coronal mass ejection collide with Earth's magnetic field, they can trigger what is known as a geomagnetic storm. A geomagnetic storm is a disturbance in the magnetic field that surrounds our planet. While these storms can create dazzling auroras in the night sky, they can also bring serious challenges to human technology. Strong storms have the power to disrupt satellites, confuse navigation systems, interrupt radio communication, and even overload electrical power grids. One famous example happened in the year 1859, known as the Carrington event. Telegraph systems around the world sparked, caught fire, and some even worked without being connected to power. Scientists believe that if a storm of similar strength struck today, it could cause massive blackouts and damage critical infrastructure across the globe. Geomagnetic storms show us that while the sun gives us life, its power can also reach across space and remind us of our vulnerability in a technological world. Fact number 36. The sun does not stay equally active all the time. Instead, it follows an 11-year cycle known as the solar cycle. During this cycle, the number of sunspots on the surface of the sun rises and falls. When the sun is at its most active, called solar maximum, sunspots are numerous, and solar flares and coronal mass ejections become more frequent. When the sun is quieter, called solar minimum, sunspots nearly disappear, and solar activity is much lower. This cycle is driven by the sun's magnetic field, which twists, flips, and reorganizes itself over time. At the end of each 11-year period, the magnetic poles of the sun actually switch places, beginning a new cycle all over again. The solar cycle affects more than just the sun. It also influences space weather around Earth, changing the strength of auroras, the impact on satellites, and even the conditions astronauts face in space. The solar cycle is like the heartbeat of our star, pulsing steadily across the centuries. Fact number 37. The activity of the sun can influence the climate on Earth in subtle but powerful ways. When the sun is more active, it releases more radiation and more charged particles into space. This can slightly warm Earth's atmosphere and change patterns in the upper layers of air. When the sun is less active, the opposite can happen, allowing Earth to cool just a little more. One famous example is a period in the 1700s known as the Maunder Minimum. During this time, sunspots almost completely disappeared for several decades. Records from that era show that Earth experienced colder winters, frozen rivers, and what is sometimes called the Little Ice Age. While the sun is not the only factor that shapes Earth's climate, its cycles of activity are an important influence. They remind us that our world is part of a much larger system, where the moods of a star 93 million miles away can still touch life here on Earth. Fact number 38. Among the most dangerous events caused by the sun are solar proton storms. These storms occur when the sun hurls out high-energy particles, mostly protons, at incredible speeds close to the speed of light. On Earth, our magnetic field and thick atmosphere protect us from most of these particles. But in space, far from this shield, solar proton storms can be deadly. Astronauts outside the safety of Earth's magnetic field could be exposed to intense radiation, which can damage cells and increase the risk of illness. Spacecraft and satellites are also vulnerable. A strong solar proton storm can interfere with electronics, damage instruments, and even shorten the lifespan of satellites orbiting Earth. This is why space agencies carefully monitor the sun. If a storm is detected, astronauts aboard the International Space Station are instructed to move to shielded areas for protection. Solar proton storms remind us that traveling beyond our planet requires constant respect for the power of the sun. Fact number 39. Most auroras are created when electrons from the solar wind collide with Earth's atmosphere. But sometimes the sun sends storms of protons instead. These create a different and more mysterious display known as a proton aurora. Unlike regular auroras, which paint the sky with bright waves of green and red. Proton auroras often appear faint, ghostly, and harder to see with the human eye. They may look like dim patches of light, barely glowing in the darkness, yet they stretch high into the atmosphere. Proton auroras are produced when fast-moving protons from the sun strike atoms in the upper atmosphere. The energy from these collisions creates subtle light, a hidden reminder of the sun's storms. While they do not shine as brightly as the classic auroras, proton auroras reveal just how many different ways the sun can touch our skies. They are like whispers from a storm 93 million miles away, faint but full of meaning. Fact number 40. The sun is not only the source of our light and warmth, it can also disrupt the very technology we depend on every day. During strong solar storms, the burst of energy and charged particles can interfere with satellites, communication signals, and even the power grid on Earth. For example, solar storms can disturb GPS navigation, making it difficult for airplanes and ships to find their correct paths. They can also disrupt radio communication used by pilots, sailors, and emergency services. Satellites that orbit Earth may experience glitches or permanent damage to their circuits, which can be extremely costly to repair or replace. One of the most serious risks is to power grids. When solar storms hit Earth, they can induce strong electric currents in long power lines, sometimes causing massive blackouts. A famous case happened in 1989 in Canada, when a solar storm left millions of people without electricity for hours. The sun still has the power to reach into our daily lives and affect modern technology in ways we cannot ignore. Fact number 41. Even though the sun is 93 million miles away, the light it produces reaches Earth in only about 8 minutes and 20 seconds. This incredible speed is because light travels faster than anything else in the universe. When you step outside on a sunny day, the warm sunlight touching your skin is already 8 minutes old. You are not feeling the sun as it is right now, but the sun as it was just a few minutes ago. This also means that if the sun suddenly disappeared, we would not know it instantly. For those brief 8 minutes, the sky would still look bright until the last rays of light finally reached us. This fact shows how vast space really is. The sun seems close, yet its light has to cross a huge distance before we can see it. Every sunrise is proof of light's incredible journey across space to reach our world. Fact number 42. Deep inside the sun, at its core, energy is created through nuclear fusion. In this process, hydrogen atoms are pressed together under enormous pressure and heat, forming helium and releasing an incredible amount of energy. You might think that this energy shoots straight out to the surface, but the journey is far from simple. In fact, a single photon of light created in the sun's core can take thousands, even millions of years to reach the surface. This is because inside the sun, particles are so densely packed that photons are constantly absorbed and re-emitted, bouncing around like a pinball trapped in a maze. Only after this long, slow journey do the photons finally reach the surface of the sun and then travel freely across space to reach Earth in just 8 minutes. So, when you see sunlight today, you might actually be looking at energy that was born millions of years ago in the heart of the sun. Fact number 43. The sun is so massive that it could fit more than 1 million Earths inside of it. Imagine lining up tiny blue Earths, one after another, until the entire ball of the sun is filled. That is how enormous our star really is. The sun's diameter is about 109 times larger than Earth's diameter. If Earth were the size of a small marble, the sun would be as large as a giant beach ball. Even though the sun is not the biggest star in the universe, its size is still beyond anything we can easily imagine. Its powerful gravity holds all the planets, moons, and countless other objects in orbit, keeping the solar system together. This fact reminds us that Earth, as large as it seems to us, is only a tiny speck compared to the star that gives us light and life. Fact number 44. The sun contains almost all of the mass of our solar system. To be more exact, it makes up about 99.8% of the total weight of everything that orbits around it. That includes all the planets, moons, asteroids, and comets combined. This incredible mass gives the sun a powerful gravity, strong enough to hold the entire solar system together. Without this gravity, the planets would drift off into space instead of following their steady paths around the sun. It also means that when we think about the solar system, we should not imagine it as planets being the main characters with the sun in the middle. The truth is, the sun is the main body, and everything else is just a small fraction orbiting around its massive presence. In other words, the solar system is really the sun's system, and we are just passengers held safely by its gravity. Fact number 45. The sun is not just a giant ball of hot gas. Its immense gravity is so strong that it actually bends the fabric of space and time itself. This is a concept explained by Albert Einstein in his theory of general relativity. Think of space as a stretched rubber sheet. If you place a small ball on it, the sheet bends just a little. But if you place a massive bowling ball, the sheet curves deeply. The sun is like that heavy ball. Its mass warps space and time, creating the curved paths that planets follow as they orbit. This bending of space is not just theory. Scientists observed it during a solar eclipse in 1919, when starlight passing near the sun was seen to bend exactly as Einstein predicted. So, every orbit in our solar system, from Mercury to distant Neptune, is shaped by the invisible curves in space and time created by the sun's gravity. Fact number 46. The sun is not just a glowing ball of fire. It has several layers in its atmosphere, each with its own unique features. Starting from the inside, there is the photosphere, which is the visible surface we see as the bright disk of the sun. Above that lies the chromosphere, a thinner and hotter layer that often appears as a reddish glow during a solar eclipse. But the most mysterious layer is the corona. The corona is the sun's outer atmosphere, stretching millions of miles into space. What makes it strange is that it is far hotter than the surface below it. While the photosphere reaches about 6,000 degrees Celsius, the corona can soar to several million degrees Celsius. Scientists are still trying to understand how the corona becomes so extremely hot. The corona is also where solar winds are born, streams of charged particles that travel across the solar system and shape space weather. During a total solar eclipse, the corona appears like a glowing crown surrounding the darkened sun, reminding us of the hidden layers that make our star so fascinating. Fact number 47. The sun is constantly blowing out a stream of charged particles known as the solar wind. This wind flows in every direction, filling the solar system with a river of energy and particles that never stops. The solar wind is made mostly of electrons and protons that escape from the sun's outer atmosphere. The corona. Even though these particles are invisible to us, they travel at incredible speeds, sometimes faster than 1,000,000 miles per hour. The solar wind shapes the space environment around every planet. On Earth, it is deflected by our magnetic field, which protects us from harmful radiation. When some of these particles slip through near the poles, they create the breathtaking northern and southern lights. In the vastness of space, the solar wind stretches far beyond Pluto, forming a giant bubble around our solar system called the heliosphere. This bubble is like a shield, protecting us from many cosmic rays that come from outside the solar system. The solar wind reminds us that the sun is not quiet. It is constantly reaching out, touching every corner of its domain. Fact number 28. On the surface of the sun, dark spots often appear. These are called sunspots. They may look small from far away, but many sunspots are larger than the entire Earth. Sunspots appear dark because they are cooler than the surrounding surface. While the photosphere of the sun can reach about 6,000 degrees Celsius, sunspots are around 4,000 degrees Celsius. Still extremely hot, but cooler compared to their surroundings, which makes them look darker. Sunspots are caused by tangled magnetic fields inside the sun. These magnetic fields block the normal flow of energy, creating cooler regions. Sunspots usually appear in groups and change over days or weeks, slowly moving across the sun's surface. The number of sunspots also rises and falls in a repeating pattern. Following the 11-year solar cycle, more sunspots often mean more solar storms and more powerful activity from our star. Fact number 49. The sun goes through a repeating cycle of activity that lasts about 11 years. During this time, the number of sunspots, solar flares, and eruptions of plasma rises and falls in a predictable rhythm. At the peak of the cycle, called solar maximum, the sun is restless. Sunspots appear